Hello! In this video, we are going to prove the following theorem. Suppose x is a real number and x is non-zero. Then the reciprocal of x is non-zero. Now, in this series, we are using a list of 10 axioms for the real number system. And I'll leave that list of axioms in the description of the video below. Now, in proving this theorem, we're going to be using the following axioms. We have axiom 6, which tells us that there exists a real number that we call 1, which is distinct from 0 and has the property that 1 times x equals x for all real numbers x. We have axiom 7, which tells us for every non-zero real number x, there exists a real number which we call the reciprocal of x that has the property that x times the reciprocal of x is equal to 1. And in proving this theorem, we are also going to be using a property that we've proven about the real number system. And that property is as follows. We have proven for all real numbers x, x times 0 is equal to 0. And I'm just going to call this property star. Now, notice in this theorem, we are given a real number x that is non-zero. So, according to axiom 7, we can make sense out of the reciprocal of x. But axiom 7 doesn't tell us that the reciprocal of x is non-zero. The whole point of this theorem is to prove that the reciprocal of x is non-zero. So, how do we prove that? We're trying to prove that the reciprocal of x is non-zero. And to prove that, well, assume for a contradiction, we instead have that the reciprocal of x is equal to 0. Then, applying axioms 7 and star, we observe the following. First of all, by axiom 7, we know that x times the reciprocal of x is equal to 1. But the reciprocal of x is equal to 0. So we have x times 0, but according to star, x times 0 is equal to 0. So what we see here is 1 is equal to 0. But according to axiom 6, 1 is distinct from 0. So we have 1 is equal to 0 and 1 is not equal to 0. So we have a contradiction. Our assumption that the reciprocal of x is equal to 0 led us to a contradiction. So we must instead have that the reciprocal of x is not equal to 0. And that is exactly what we wanted to prove. So this completes the proof. And because we know that the reciprocal of x is non-zero, now we can make sense out of the reciprocal of x, right? Because remember, according to axiom 7, we can only take the reciprocal of non-zero real numbers. So now we can make sense out of the reciprocal of x. And so yeah, that's pretty much it for this video.